I mean, when you're talking about complexity, it's really hard to know where to start and where to finish. And I guess the different in this series will give you different perspectives on complexity. So I thought what I'd focus on today, and I apologise that part of the bottom of the slides is missing, so I don't think you'll miss too much there, but you do have your handouts. My take on it is that as a scientist, I started off my life thinking that if only we had enough information, we could solve all problems. As I went along, I started to realise that there's a lot of stuff that we'll never have enough information about to really understand or to predict. And I guess one of the things that I also became the fact that complexity, while it is a problem in its own right, we make it worse because as humans we tend to try and simplify everything and imagine that they can be predicted. And in doing that, we make it a whole lot harder to deal with complexity. So that's the sort of unhelpful thinking that I'm referring to. So I'll talk today about a range of different ways that we can try and embrace the uncertainty that is associated with complexity and therefore deal with complexity in a much more constructive sort of way. I've added 2 slides since I sent the stuff for printing. This is one and there's one right at the end. I just wanted to throw in this quote from Peter Schwartz, who's one of the sort of gurus of strategic thinking, because it really in a nutshell summarises for me what I think unravelling complexity needs to be about. It's not about helping us to be able to predict the future better. We can't do that, and the more we kid ourselves that we can, the more we make ourselves vulnerable to surprises. So it's about trying to embrace complexity, embrace uncertainty, and deal with them so that we can make better decisions. So I hope if nothing else, you remember that. So what I want to do today is start off with some definitions, what I mean by complexity, for example. Go on and talk a little bit about the sort of attitudes people have towards complexity, many of which make it hard for us to deal with it. And then spend most of the time talking about a range of different approaches to dealing with complexity and uncertainty. If I have time, I'll say a little bit about thinking flaws and other constraints on good thinking about complexity. If we don't have time, some of the reading that you've been given for the tutorials covers that area. And then I'll just finish off with some comments about how I think what I'm saying today might be relevant to the course. So this is a circuit board, and I think you'd all agree it's very complicated. But it is, in theory, possible to understand everything that does and to predict it. So if you keep giving the same inputs, you'll get the same outputs every time. So that's a complicated system, but not a complex system. Now, the systems thinkers distinguish complex systems from complicated systems in a number of ways. Firstly, complex systems, it's difficult to know where the boundary is. So, for example, if we were to think about the social system we've got happening in this room, it doesn't finish at the doorway because many of you are connected to things that are going outside. In fact, you all are. And in the same way, ecosystems, it's very hard to draw a boundary around where a particular community of plants and animals lives because they'll always have interactions with a few more a bit further down the track. Very often, complex systems are not in equilibrium. They tend to have memory. Things that happen in the past affect what's happening now. And that's really obvious in human systems where our experience means we behave differently now to what we might have in the past. But equally in plant and animal systems, things that have happened in the past constrain the way they act now. They tend to be nested. There's systems within systems. The jargon, I can't even remember the jargon. It's something like to do with dynamical complexity or something, but what it means is the sort of interactions that go on in complex systems, in networks, can be all closely and tight in one place and strung out in other parts, and they change from time to time. Complex systems are not just cause and effect, so if I do this, that happens, that happens, that happens. If I do this in a complex system, that might happen or that might happen, and it might happen differently at another time. And they've got feedback loops, which means that if you do something, something else can happen, and you can get a string of things that comes back and affects the thing that you're actually doing. So you can get snowball effects, where when you do something, the effect keeps getting stronger and stronger, or you can get vicious cycles where things just get worse and worse and worse, and it's hard to stop. So I'll talk about ways that people have come up with to try and deal with that. But that's what we're talking about as systems people when we're talking about complexity. And by and large, you find most of the speakers, I think, are talking about things like that, although they might have different takes on it. Now, there's a special type of complex system that we're all part of, which is complex adaptive systems. These are really even harder to understand because the rules keep changing, because they've got agents in them. Very often they're people, but they can be other animals that learn and behave differently as they learn, and so the rules keep changing. So you can see there's examples there of complex adaptive systems. So I think you're starting to get a feeling for why we can't predict what complex systems are going to do. And then chaos in systems is another example of complexity, and another lecturer will be talking specifically about that later on in the course. Now, uncertainty, I could go on and on and on about what uncertainty is, of course, and some uncertainty comes because we don't have enough knowledge, and some uncertainty comes because of the sort of behaviour that we have or the way we approach complexity. The point I want to make today, though, is that uncertainty is one of the consequences of complexity, because, as I said, we can't predict what's happening in complex systems. And our failure to acknowledge that uncertainty makes it harder for us to deal with complexity. And I'll give you some examples of that. A minute between now and the end of the day, you know that you can't do that. But when you go home tonight and your partner or your flatmate or whatever says, "How was the day?" you'll probably say, "Oh, pretty much as I expected." We fool ourselves in retrospect into thinking that randomness was actually predictable and expected. So it's a fascinating take on the world. But the example that where the name of the book comes from is a classic example of the sort of fallacy of thinking that we often get into. The first black swan that was taken back to the United Kingdom from Australia was greeted with great scepticism, because every swan that scientists in England had seen up till that time was white, and they'd fallen into the fallacy of thinking because every swan they'd seen was white, then all swans were white. It's a classical thinking fallacy, but it's an example of one of the sort of fallacies that we all fall into. And I'll say some more later about that. So I just want to say something about the attitudes that people have to complexity, because this is one of the things that makes it hard for us. If we think about the future as things that we've got more or less control over and things we've got more or less certainty about, the place that we like to be as humans is up in this right-hand corner, where we've got control over what happens and we've got certainty. And there are some things that fall into that category, but that's the area that we like to be in. Very often in organisations, we build our plans around that. We restrict our view of the world to only think about the things we've got control of. And if there are things that we're uncertain about, we tend to try and make them certain. So if you take, for example, the Y2K bug that was supposed to destroy all our computers at the turn of the millennium, that was a possibility, not a certainty, but we had to turn it into a certainty. And so when it didn't happen, everyone said, "Oh, gee, we were all wrong." But in fact, it was only a possibility. Now, sometimes we stray out of that corner and we get into areas where we've got some control but not much certainty, and there we use adaptive management. Or we get into areas where we've got some certainty but not much control, and we hedge our bets. But the area that we steadfastly avoid is this bottom corner where we don't have control and we don't have certainty. Our science doesn't predict for us what's going to happen. And the best thing we can do is plan for surprise. But we don't like doing that. We don't feel comfortable. So mostly we tend to ignore that quadrant. When it comes down to planning, the most common form of planning is optimal control. As I said, we sit up in that top corner, we deal with the things we can control and we're certain about. A lot of people who've been around for a long time know that these sort of plans invariably don't work. And so rather than going to the third possibility and develop a strategic navigation approach where you've got flexible plans, they adopt the attitude, well, why bother? We'll just go through the process of doing strategic plans because we know they're not going to work anyway. And so those top two is the prevailing attitude that you find in organisations, unfortunately.